Hey guys, today's video we are going to pick up where we left off on the graphing. Oops, excuse me, that kind of got moved a little bit. On the graphing of the parent function of cosine, okay? So first I just want to say that I am a little bit sick, so I just want to kind of let you know that. So if I'm coughing in the middle of the video, it might be a little bit louder than my normal voice. So I apologize for that right now. But first, I just want to see if you guys remember how to graph your parent function of sine, right? Remember how we graphed out the parent function of sine? We would use the unit circle to find all of our inputs and all of our outputs. Okay, so we're going to be doing the same thing today. But first, let me move this closer so you're going to see a little bit of movement, and here we go. Zoom in a little bit. All right, so there you go. Perfect. We have the parent function y equals f of x, which is the same as y equals, except f of x is denoted as the function of x equals a cosine of x. So I'm just going to draw out my unit circle again. I will always draw out the unit circle. It's easier for me. It's a visual. Many of us are visual learners, right? So if you are a visual learner, draw it out and label these key points, okay? So this is a unit circle, so x is 1, y is 0. This is a unit circle, so x is 0, y is 1. Negative 1 comma 0 and 0 comma negative 1. So I'm going to be using 5 inputs. Okay, 5 inputs. And I will explain to you what those are. So for my parent function, f of x equals cosine of x, my 5 inputs are, here's my input, here is my output. When x is 0, okay, so that means my angle is 0. What is my output for cosine? When x is 0, cosine is 1. So when x is 0, cosine of 0 is 1. When x is pi over 2, cosine of pi over 2 is 0. When x is when x is a pi, half a circle, cosine of pi is negative 1. When x is 3 pi over 2, cosine of 3 pi over 2 is going to be 0. And my fifth value, because I need to go a full circle, so 2 pi is where, because 0 is where we started, 2 pi is where we are going to end up. So 2 pi, cosine of 2 pi, which is the same location as 0, is going to be 1. So those are our values. So let's talk about the period and amplitude. Okay, so period is going to be 2 pi divided by absolute value of b. Remember this? And b, if you guys remember, in the definition before, I had this equation. Okay, y equals cosine of b of x, right? Cosine of bx. This is sort of the way that it's read. So b is behind the word cosine, in front of x, which is a horizontal compression or stretch, depending on what b is. Since the parent function has 1 in front of x, so my b is 1. So 2 pi divided by absolute value of 1, it's really 2 pi. So the period 2 pi. So I'm going to go and graph 2 pi here, and I want to do 2 full cycles on the right, 2 positive full cycles, and even a negative cycle, which is negative 2 pi on the left. Okay. And so I'm going to talk about the amplitude again. The amplitude is absolute value of a. Well, this is sort of y equals a times cosine of bx. Our parent function is f of x equals 1 times cosine of 1x. So a is 1, so my amplitude is 1. So I'm going to go as high up as 1 and as low as negative 1. Let me find a different color pen so it's not as light as this blue. Okay, so just hold on tight. Do you think green would be better? Let's see. Okay, there you go. So I'm going to go in and every single cycle or period, I'm going to make 4 equal intervals, okay? 4 equal intervals. So the next cycle, I'm going to make 4 equal intervals, half, and then half of half. Okay, so a quarter. I'm going to label a couple of these. Okay, from 0 to 2 pi, right in the middle is going to be pi. Well, in the middle, from 0 to pi, is going to be pi over 2. So each tick mark is worth a pi over 2 radian or unit, okay? In this case, your unit measurement is radian. So when the input is 0, y is going to be 1. When the input is pi over 2, output is 0. So pi over 2 is here. When the input is pi, output is negative 1. When the input is 3 pi over 2, which is the next tick mark, 1 pi over 2, 2 pi over 2 reduces down to pi. This is 3 pi over 2. I'm saying at 0. When the input is 2 pi, I'm going back up at 1. So I'm just going to repeat my dots, okay? So check out this dot. These two are the same, so the next one to the right will be staying at 0. The next one will be go down to negative 1. The next one over is staying at 0. The next one over is going to be back up at positive 1. So here are the connection of all these dots. This is the cosine curve or wave, right? So because I can't go up any higher because my amplitude is 1, this is the highest I'm going to go, so I'm going to make an arrow looping back down. And I'm just going to repeat over here. So if you look at this, my highest is at 1, so a left will be staying at 0. 2 lefts over is negative 1. The third left is going to be staying at 0 and back up at positive 1. So connect this dot, connect that dot, connect this dot. So looping back down to make it my arrow. So this is a cosine wave or cosine curve, okay? The difference between the two, let's look at this, okay? The difference between the two, at 0, cosine is positive 1. Sine, at 0, the output is also 0. Okay, so that's the difference. Now, but besides that, notice how these two are almost the same thing, except that all I have to do is I can take this cosine, right? Could I just move over to the right a little bit? What happens if I take this cosine and move over to the right by pi over 2? Would you agree that I would have exactly the same thing as my y equals sine of x curve? So that's what it is. These two are almost identical, except that you can take one function. Okay, if I take the sine curve, and all I have to do is move to the left, okay, move to the left by pi over 2, then I would be at 0, 1, and that would be my cosine curve. So sine and cosine, they are so similar, except all you got to do is pick it up and move it a little bit left or right. So let's talk about the domain. The domain of cosine is similar to your sine, which is going to be negative infinity to infinity, or aka all reals. Your range is going to be from negative 1 to positive 1. Symmetrical. If you look at this, this is symmetrical about the y-axis, so this is an even function. Okay. Period, we found it earlier. Period is going to be 2 pi. X-intercept, let's look at this. So let's do some work here for x-intercept. Because I think the x-intercept and the maximum and the minimum, these three are, I believe, more confusing than the rest because you have to use the k value in there and you have to define what k is. So x-intercept, I'm going to make a list, okay? This is a positive pi over 2. This is a positive 3 pi over 2, so I'm going to write pi over 2. The next one is 3 pi over 2, 4 pi over 2, 5 pi over 2. And this is 6 pi over 2, 7 pi over 2. So all of these are where your x-intercepts are. Dot, dot, dot at the end. Dot, dot, dot. And then on the left, negative pi over 2. Negative 3 pi over 2. Dot, dot, dot. Okay. So when you are making a pattern, you want to list out as many values as you can so you can have a better pattern. So if you look at this, would you agree that the first x-intercept is pi over 2? I would have 2. The difference between pi over 2 and 3 pi over 2 is if I add 2 pi over 2. Would you agree with that? So 1 pi over 2 plus 2 pi over 2 is really 3 pi over 2. But 2 pi over 2 reduces down to a pi. So if you look at it, so from here to here, would you agree that I will also add 2 pi over 2 to get 5 pi over 2? And similarly. How about from here to here? if I take negative pi over 2, add 2 pi over 2, I would end up with a positive pi over 2. So the pattern holds. So the x-intercept is going to start with the smallest positive here, pi over 2 plus, I'm adding pi every time, right? And so pi k. So, and where k is any integer, where k is any integer. And let's check it again. You don't want to just write it and then leave it. We want to check to see if what we wrote down makes sense. So when k is 0, do I have an x-intercept at pi over 2? Check. When k is 1, 1 times pi is pi. Pi plus pi over 2. Well, pi, if I were to convert it, is really 2 pi over 2. So pi over 2 plus 2 pi over 2 is 3 pi over 2. Check. Okay, so those work. How about when negative values? When negative 1, well, pi over 2 plus a negative 1 times pi is negative pi. So it's really pi over 2 subtract pi. So pi over 2 subtract 2 pi over 2, because if I had to reduce that, then I'm going to end up with the negative pi over 2. So that works as well. So for right now, this equation right here holds. All right, maximum value, again, is at 1. I'm sorry, is 1. And at, okay, so let's look at all the maximum points. So at 0, the next one is 2 pi. The next one is 4 pi, dot, dot, dot. And this one over here is negative 2 pi. And I'm going to do dot, dot, dot on the left as well. So let's see. The first positive one is 0. So if I add 2 pi each time, that works. Or I can multiply 2, right? So would you agree that it's going to be 0, add 2 pi? That doesn't make sense, right? So, because I don't want to write 0 plus 2 pi, because who does that? So you can just say 0 plus 2 pi is the same thing as 2 pi, and times k. Okay, so if k is 0, I would have 0. Perfect. If k is 1, I would have 2. If k is 2, I would have 4. So all of that works. If k is negative 1, I would have negative 2. So that works. And k can be any integer, where k is any integer. Okay. And minimum. So let's go and talk about the minimum. Minimum value is negative 1. The lowest value is negative 1. And let's see the locations. The first one is negative, looks like negative pi, dot, dot, dot on the left, comma. The next one is positive pi. And this is positive pi, 2 pi, 3 pi. Okay, dot, dot, dot. So if you look at it, I'm adding 2 pi again. So you can say multiple things here. You can do 2 pi minus 1. Okay, that works. So I'm going to give you a couple of different equations, right? I can do 2 pi minus, let's see, 2 pi minus a k pi. Would that work? Okay, so let's see. Let's test this out. When k is 0, 0 times pi is 0. Oh, that doesn't work. Okay, see how, like, if you want to, you can test it out. Okay, so how about if I go, hey, if I'm just going to add each time? Or what if I do pi plus, from here to here, I'm going to do 2 pi k. Is that going to work? Okay, so let's test it out. When k is 0, then this is 0, then I would have a pi. Check. When k is 1, 1 times 2 is 2 pi. Pi plus 2 pi is 3 pi. Check. How about when k is negative 1? Negative 1 times 2 pi is negative 2 pi. Pi minus 2 pi is negative pi. That works. How about if I were to go and do pi k? Is that going to work? Well, when k is 0, well, I have nothing. When k is 1, 1 times pi, it's pi. When k is 2, it doesn't work. But when k is 3, it works. So it looks like if I were to put in odd integers, that would be okay. So it depends on how you define your k. Okay, so this equation, if k is any integer, and this one is when k is odd integers only. Okay, so notice how the difference between the two, I can have this one, or I can have this one, and that's really up to you to pick. All right. Now we're gonna move on to example 1 because we haven't done any example for a really long time or for a while. So we are going to do example 1. Find the period and amplitude. Okay, so the period is the horizontal distance, the amplitude is the vertical distance, right? So the period for sine and cosine is 2 pi divided by absolute value of b. And b is really this horizontal change. So for this one, b happened to be 3. So 2 pi divided by absolute value of 3. That's really turns out to positive. So my period is 2 pi over 3. That means I'm going to go 2 over 3 pi and then repeat. 2 over 3 pi, repeat. Amplitude is the absolute value of a. A in this case is -4, so absolute value of -4, which is really 4. So from the center, you're going to go 4 up and 4 down. Okay. So that's what happens when we have that. All right, and then the next one, we're going to do the period and amplitude. What I'm going to do is I'm going to do the period and amplitude for C, and I'm going to leave B and D for you to do on your own. So period is going to be 2 pi divided by absolute value of B. Well, B, in this case, the horizontal change is 2, so 2 pi divided by absolute value of 2. Well, 2 pi divided by 2 is really a pi. So I'm going to go 1/2 cycle, or from 0 to pi, and then repeat. From pi to 2 pi, repeat. From 2 pi to 3 pi, repeat. That's what it means. And I'm going to do the amplitude. Amplitude is going to be the absolute value of A. A happens to be this negative right here. So that's the same thing as saying absolute value of -1, which is really a 1. Okay? So that's what's happening. All right, so I'm going to ask you to find the period and amplitude of these two. So on your own. Okay, I will check all of that tomorrow. Make sure you stop the video and do it right away, because I know how we can get. Oftentimes we said we're going to wait and then we're going to forget. Okay. All right, so let's talk. All right. Okay, well, let's just end it right here and we will continue again next time.